Hello everybody and welcome to this tutorial, how to use 3D photogrammetry to digitize a real-world object, to create then a mesh model, which then being placed in Shapr3D, we can use as a three-dimensional blueprint to model a new clean version over it. So how does 3D photogrammetry work and what do we need for it? And the good news is, it is actually a very easy process. All we need is an object, a camera. In my case, I used an iPad Pro. And we have then to create a sequential set of images. You see that I tried to frame as much of the object as possible. And I go step by step and then take a photo. This helps overlapping the object from frame to frame. After I did a 360-degree pass, I went to a different angle, now more from the top, and I tried to capture this region. And because from the top you cannot see where the feet are, then I also do a 360-degree feet more from that lower angle. I can ignore the head because that already I captured quite sufficiently. And because, for example, also this humidifier stands on this wooden ladder, which is a consistent element through all these photos, I can even then go ahead and take photos of these feet, and the software then can understand where these images exist actually in 3D space. And then to help one more time, I created another 360-degree pass, more from the front. Again, trying to capture as much as possible in nice, clean steps, overlapping frame by frame the object. And that is it. Now, with this set of images, the software can take a look at this image and compare it to the image before or the image after it, and then it can see where are similarities. You and I we see that there's actually an air humidifier. The software simply sees pixels. But by being able to compare these images, it can see how maybe similar pixels are moving. And in conjunction with the camera data, the software will figure out where the camera was positioned in three-dimensional space. It can then create a 3D mesh. So let's take a look at some of the requirements, the do's and don'ts for 3D photogrammetry. So what 3D photogrammetry does not like at all is glossy surfaces, transparent surfaces, and color-wise too homogeneous, even surfaces. It does not really like reflections, as you can see on the head of the figure, because when we move around, these reflections will change. And this will confuse the software because it does not know, is this a reflection or is this a three-dimensional structure? Transparency pretty much explains itself, because also there colors are changing. That is not very good. And when a surface is too much of the same color, the software really has an issue seeing the 3D dimension of it. So to help this, one very easy way, if you want to do it on a low cost, is simply use cornstarch, which is very thin, and then sprinkle it over the object. You can also use dry hair shampoo spray, which is more expensive, also finer. The cornstarch will result slightly into a rougher surface when we did the scan. But honestly, for the scale of the object and how I'm going to use the scan to rebuild something, this is totally fine. And because we have a gray surface under it, and here in different color, the software can read actually the cornstarch on top and then see how things are changing. Another very important aspect also is you want to have every frame in focus. Not the background, you want to have your object in focus. So I make a step, focus, take a photo. Make a step, focus, take a photo. So don't simply walk around and hit the capture button, because what can happen is that you move the device slightly a little bit and then part of your image is out of focus. Illumination is also very important. You see here in this case I did this in the evening time of the day, so harsh sunlight is not very good. The best situation is morning or evening, ideally when we have an overcast, because this is a nice soft light box then. We also don't want to have any sharp or harsh shadows on the object, because the software could read these shadows as part of the three-dimensional geometry. If you cannot take photos outside, we can still do something in the inside. But you can see how a lot of the light comes through the windows and is casting a shadow behind the object. So when we take the photos, try ideally not to be too close to the object so that your body does not cast a shadow over the object. But from my experience, as long as these self-cast shadows are not too strong, the software doesn't actually struggle with it as much. And in terms of exposure, try not really to shoot against bright objects. So here in this case, I am actually at the bottom and I'm looking more up. And you see that the window is nicely exposed, but the object is kind of darkish. Over a sequence of images, that exposure will change and can help the software to understand what's happening. But in general, we want to try to prevent shooting against too bright backgrounds, light sources, etc. And essentially, that really is everything that is important to know about 3D photogrammetry. When you have an object, let's say a small one, and you try to digitize it and you use then a dry shampoo, what sometimes also helps, because then the result can be very homogeneous again, sprinkle a little bit of maybe a colored powder over it, because then this adds another type of texture. I, in my case, very often simply use cinnamon, because cinnamon is a very finely ground material. I can sprinkle it over it and then I blow the rest away, and then I have a very fine texture on the object. On iOS, the best photogrammetry software we could use is Trinio. I use this a lot. It works on iPhone and iPad, which makes it the perfect companion to Shapr. It's very easy to use. The nice thing also, it is mobile. So that means after we created all the images for our object, the processing will take place in the cloud. And once the processing is done, we get a notification, we can download the file and then export it. As you can see by the long list of scan jobs, I use this software quite extensively for my professional work as well for my teaching. Let's take a look at our air humidifier object. This is the one that has the cornstarch on top. Now this looks quite nice. Everything that we photographed was able to be turned into geometry. Obviously, we didn't photograph from the bottom, so that area has some artifacts or is simply missing. And this is normal, because we only want to have our top area, so the humidifier, digitize. The rest later we will remove anyway. Let's take a look at this job. That's the one without any surface treatment. And when we zoom in, you can see it looks quite funny. It's like somebody was a little bit hungry. And this is what happens when you have a surface that is too uniform in color, has no texture, or is glossy, or translucent, transparent. It just simply doesn't work. And going back to here, so just sprinkling a little bit of cornstarch over it seriously helps making these surfaces very easy to capture. Okay, so let's go back here to the stage. So after the scan is done, we can then go to share, and we can share this as an OBJ file. Shapr currently does not open OBJ, it opens STL, but that's not a big deal. On a Mac or PC, we can simply use Meshlab and then convert the OBJ scan into an STL scan, and that then we can import into Shapr. So I click on share, go to files, call this Trinio scan, and I will put this into the Shapr folder. And that's it. On the computer side, I am inside the folder where we have the Trinio exported file. As you can see, this is a zip archive. So let's unpack it. Then we will get a folder with the OBJ file inside. In this OBJ file, we will open in Meshlab. Meshlab is also open source, Mac and PC, and it's free. Go to File, Import. Here is my OBJ file. And there it is. If I would like to get rid of some of the geometry, I can select some of these vertices and then actually delete everything. And maybe here one more time. There. Very good. Let's rotate to this view and we select all this. Okay, very good. So this is cleaned up a little bit, much nicer. And then we can go to File, Export, Mesh As, and we want to select the STL format, which stands for stereolithography. This is the format Shapr can import. Also change the suffix, click Save, and that basically is everything. Here now in Shape, I will quickly explain to you how we can use the software and how the process of doing 3D photogrammetry on a desktop application works. Trinio has the advantage of doing a lot of the manual work for us automatically. Essentially, all we do is just make photos and then the software generates the model for us. In Shape, we have to do a little bit of manual work. But this also is actually not very difficult to learn. The steps are quite easy, to be honest, and it gives us a little bit more of control. So in regards to the software, on the left side, the workspace, this is where we see all our individual processing steps. And then we'll go into what all this is in a minute. And then on the right side, we see our 3D model. And here we have some tools. So the first step we have to do is give the software the photos. So we go Workflow, Add Photo or Folder. I very often use folder because I have many images. Select this folder, click Open, and then it will add all these images to the scene, 113 images. After that, we have to go to Align Photos. Accuracy highest, that is very good. And what Align Photos basically means is that the software takes a look at all these images and then figures out, well, where in 3D space are these photos made? So where was I standing when I captured them? And this then generates the positional data the software can use together with how the images change to figure out where is actually the 3D mesh. I have one file prepared for this end result. There we are. There you see kind of like the humidifier on the inside. Let me turn off the images. With the mouse wheel, we zoom out a little bit, because what is important to say here is you see there's a lot in the background, and all that stuff I don't really want. I just want only my humidifier. So we have, or we can crop this area a little bit. I will use the rectangular selection, draw over the area I want, and then I select the crop tool to cut everything away. There. Now I have a lot at the bottom. I can rotate this one more time. Click, select all this, crop. Very good. Now that's all gone. And you see there is a gray bounding box around the humidifier that is kind of like the region the software works in. We can even reset it. So we trim it to it. This is now a smaller sphere for the, or area for the software to work in, and that is pretty good. Okay, so now the next step is we can actually jump into now making our geometry. Traditionally, most programs go right to now building the dense cloud geometry. I find this step to be rather slow and not really yielding that much of additional information because of advancements in photography and depth mapping. We will rather jump right to build mesh and then actually use the depth map to create the geometry. For the quality, I find the difference between high and ultra high is rather minimal. And the processing time for ultra high is quite a lot more. So I, to be honest, primarily simply work in high. When you're not very sure if your images, however, are good, meaning is every image perfectly in focus? Are maybe some parts missing? It is very good to maybe do a low quality pass to quickly see is everything fine, and then we can go and do a high pass. Alternatively, to do a quick preview, we could also switch the source data to sparse cloud. This is basically what you see here right now, and then click OK. You see now the interface tells you that it's generating the mesh already based on this point cloud it generated before. And there it is. So when I rotate around, I can see I don't have anywhere interesting holes or artifacts. So everything should be set to now go to build mesh. Use the depth map, high, and click OK. For the face count, since we want to have precision here, we want to have a high count. You can, if you want, play with medium. I would not suggest to go too low because then you might lose actually details. For example, sharp edges might be less modeled because we have a lower amount of polygons. Okay, so let's go back to our finished version. So there you see again now our aligned images, then the sparse cloud, the depth map. This is basically what the software generated to then create the 3D model. And here is the mesh. Let me turn off the texture so we only will see the geometry. And there you can see that this, compared to the preview we just generated a moment before, is much more detailed. We can even see the geometry of the dial there. Beautiful. And when we zoom in a little bit, you can see there is some sort of noise on the surface, and that is actually the cornstarch. So it's that small or that flat, but the software is that good that it can actually see it. We can smooth that out. via a mesh algorithm or simply leave it in, because all I need here to do is just capture this model as closely as possible, because I still have to rotate and scale everything, so it won't be like 100% accurate match anyway. This will function as like a three-dimensional backdrop to model over. So when all this is done, then all we have to do is go export, export model, give this a name, and we save this as STL, specify where it should go to, click save, and that is it. In Shapr now we can set up our scene and then import our STL file. First thing what we want to do is make sure we are inside a usable unit system. Our object is not that big, so centimeter will be very good. We also want to have our snapping system turned on, since we will use this a lot too. Very good. Let's go to import. Then we will navigate to where we have the STL file. There it is, and select it. Shapr now will ask you what unit system to import it with. And when you don't really know which one to select, not really a big problem. We have to probably rotate and manually scale this object anyway. So I will simply select centimeters, click done. Then this will take a moment to process. And there it is. There we can see it. Quite rotated and not positioned correctly. So the task we have to do now first is try to rotate it. Then we place it in the center, and then we can scale it. And this object has actually a dial at the center, which we can measure in real life. It has actually a diameter of 4 centimeters, and then we just make a 4 centimeter circle and use it to scale the object towards it. But before, let's rotate it. So we go transform, move and rotate. Select the object, and top view, we can rotate it a little bit. Very good. Go to front view. The 3D widget here I will move down, then this is more planar to my view. I can rotate it like this. Sometimes we have to also enter the values more by hand. Let's go to this view. Okay. So there we can see that also here we have to rotate this a little bit. I can use actually the grid to get an understanding of how far is maybe the ground rotated correctly. You notice when I move the widget onto the mesh, then it straightens it out a little bit more. Now I move this one straight up and over there, a little bit lower, and I try to put it onto the grid. Yeah, this looks okay for the moment. Go to this view and we can move this to there. Okay, let's take a look at the top. How does this look? Yeah. So one thing or few things to keep in mind. Your eyes can be very easily be fooled. Be aware of that. So don't think the object looks straight, because quite often it's not perfectly straight. Manufactured objects are also not 100% perfect. So don't try to perfectly align and scale this object as closely as possible. At one point, it will be fine. Anyway, we also use the scans more as a helper to quickly capture or have a three-dimensional reference. So how do we continue now with trying to position this correctly? What I will do first is I will go to a top view, make a sketch, make a circle, and then add a circle here. Okay, so this circle, for example, is very useful because it tells me how how off actually my object is. So I will go to transform, select my object, zoom in a little bit, and then I try to center it better on my circle. There, this actually looks much better. Okay, very good. Now from this view, let me show you another interesting trick. What we could do, I will create a sketch, simply draw a line down here, and then I draw a line there, and a line there, and a line there. Okay. And I can draw a line here too, and then these 2 points I can make symmetrical to this line. Okay, this line moved, so I will bring this back onto the grid and snap it. There and there. And I can do this here again. And there. Okay, so why this is very useful is I can then go ahead, select this point and move this closer, and now I compare the left and the right side. How close are they? And in our case, this looks actually pretty good. So let's take a look here. Yeah, very close too. So it seems that along the y-axis, at least the main body is rotated. Good. What about the feet? So here and there. So I can select this point and this point, make this symmetrical to here. Very good. So there I can see that maybe the object is slightly rotated. So we can go to here, and then I will drag the 3D widget to this line I created, and I have to rotate it just a little bit this way, maybe by 0.25 degrees. Then let's go to this view. This was actually too much, so maybe minus. And okay, maybe minus 0.5. One. That's not a big deal to try to work very careful there. This starts to actually line up really good. Okay, very nice. So also along that axis, the object is created perfectly. Now I also noticed that my my whole design is also on the ground, so I have to rotate it. So you see Z is actually up. So I can select transform, select my object, then move the 3D widget here to the center of the circle, and then we will rotate this 90 degrees. Very good. All these sketches we don't need anymore. We can remove them. Also here we might have an artifact. There's a little fragment. We simply delete it. And now we can go ahead and try to scale everything. Good. So I set the front dial is 4 centimeters in diameter. So let's make a sketch. This should be 2 centimeters. And there we can see that our object is actually quite small. I will bring this one up. Try to somewhat position it there. Very good. Select our mesh object. Then I go to scale. And you see I moved the scale widget to the circle and snaps to the center. Perfect. Because now I can scale the mesh up. And there it starts to overlap with the sketch. Very good. The sketch, as you see, is also at the center of my object, so I scaled everything from the center away, so this is perfect. We can do a quick check. Does this line up? This lines up actually really good. There. We could also select the sketch if we want to make a copy and move this one up. So when I go to this view, then I can see a little bit more how far this all lines up. We actually rotated everything so the feet are fine, but now we can see that the dial is a little bit off. And this is actually good to see because this will be a warning from my side not to try to be too precise. There's also inaccuracies in models which are created via 3D photogrammetry, and there are inaccuracies in models which are manufactured too. So keep that always in mind. But with this basically done, all we have to do now is, since we scaled it from the style, we want to put our object back onto the ground, like there. Very good. And this is our back. We want this to be the front, then one more rotation. By 180 degrees. This now we can remove. And we're done. Now we can go ahead to create sketches, so we could try to rebuild this humidifier in Shapr.